today we're looking at lesson 4-5, which is determine the number of solutions. Now, this part, you guys, you don't have to write down. This is just for me, okay? So it says the solution to an equation is the value of the variable that makes the equation true. So we've been doing that all along. We've been solving equations and we're saying x equals this, t equals this, right? That's one solution, okay? Some equations have the one solution while others have no solution, okay? When this occurs, no value will make that equation true. Other equations may have infinitely many solutions. When this occurs, the equation is true for every value of the variable. Now, we just talked about the one solution. When we have no solution, you guys have any idea what it looks like when they, like if we're looking at a graph, if it has no solution, what does it look like if we graph like a linear equation that has no solution? So when there's no solutions, when we graph it, it looks like two parallel lines, okay? Because when you have parallel lines, there is no intersection, so there is no solution. You got that? So what do you think the graph of the equations will look like if they have infinitely many solutions? So when we have infinitely many solutions, then they are the same line, okay? So we're going to learn today how to show that mathematically, okay? All right, so here on this table just organizes what it looks like, okay? So if we have no solution, we have two numbers that are not equal to each other. That's what's going to look like when we solve our equation. It's going to look like this. 4 does not equal 0. That's what it's going to look like. When you have one solution, it's going to look like all of our work that we've been doing for the past couple weeks, right? X equals 10. T equals 4. That's what it's going to look like. The infinite solutions, it's going to look like something equals something, like 2 equals 2, 8 equals 8, 10 equals 10, -5 equals -5. It's going to be equal on both sides when we finish solving, doing all the steps for solving the equation. For example 1, we want to look at equations with infinitely many solutions. And we want to know which one of these has infinite number of solutions. Okay? So, everybody write down your title. Write down the name of the title this time because they're all different. And then write down the first example, the first equation. So the first step we're going to do is we're going to use the distributive property. So we're going to take that 8 and we're going to distribute throughout the parentheses. We're going to take that 6 and we're going to distribute throughout the parentheses. So tell me what to write here. 8 times x equals 8x. Then minus 72 is equal to 12x minus 72 minus 4x. So now we're going to combine our like terms. So we've got, on the right-hand side of my equal sign, I've got a 12x and a 4x. Now, on the right-hand side, we've got 12x minus 4x, which is 8x. So we have 8x minus 72. And then we're just going to bring down 8x minus 72. Now, you already can see it's going to be the same on both sides, but we're going to finish until we get to just the constants, okay? So we can combine our x terms. So now, because those are both positive, we're going to subtract 8x on both sides. Those cancel to 0, right? And then we've got 0 minus 72 is negative 72, and 0 minus 72 is negative 72. So because this says the same thing on both sides, this has infinitely many solutions. Is everybody clear? This one is infinitely many solutions. So infinite many solutions. Is everybody clear? All right. So now let's do the second example. All right. So first we're going to use our distributive property on both sides. And again, let's draw our dotted green line just so we can keep ourselves straight. All right. So when we use our distributive property, what are we going to write here? 5x minus 10, bring down the minus 20 equals negative 5x plus 30. Very good. Very good. So now we've got constants on the constants on the left-hand side. So we're going to write 5x minus 30, right? So negative 10 plus negative 20, negative 30, is equal to negative 5x plus 30. Now what? I'm going to add 5 on both sides, 5x. So add 5x, add 5x on both sides. So those cancel to 0, and we're left with 10x minus 30 is equal to 30. Now what? Add 30 on both sides. So we want to add 30 on both sides. So those 30s over here, those cancel to 0, and we're left with 10x is equal to 60. Then to get the x by itself, we will divide by 10 on both sides. Oops. Right. So we get x is equal to 6. And of course, obviously this is one solution. Is everybody clear? One solution. Example 2. We want to know which equation has no solution. Now, if it has no solution, what's it going to look like? Yes, parallel lines, but what does the equation look like? Not the same on each side. It's going to be not equal to each other, right? So it's going to be like a 3 equals 5, like that, okay? So let's start with our distributive property. All right, so we are going to use our distributive property. So we're distributing that 3 throughout the parentheses. Okay, and what are we going to write next? 3x plus 15 equals plus 15. Very good. Minus 2x. All right. Now, again, here's my equal sign line. And now I'm going to combine some like terms, right? So, and negative 2x, which gives us 3x. Very good. So on this side, we've got 3x plus 15. And on the other side, we've got 3x plus 15. You can already see this has what? Infinite many solutions, right? Well, we'll see. We have to prove it, okay? So let me finish this. We're going to subtract 3x on both sides. So those cancel. And we want to just keep on going until we just have the constants, okay, guys? So then this is going to be 15 is equal to 15, which means infinite solutions. So that other one, probably yes. Going to be no solutions. Let's prove it. Okay? So we're going to use our distributive property. So what are we going to write? So we're going to negative 10y plus 18 equals negative 15y plus 21, because remember that's negative 3 times negative 7, that's plus 21, plus 5y. Everybody good? All right, here's my equal sign line. And I can see I got some like terms on the right-hand side. So we've got a negative 15y and a positive 5y, and that's going to give me negative 10y. So we've got negative 10y plus 21 on that side. And on this side, we've got negative 10y is equal to 18. Oh, I'm sorry. Plus, yes, thank you. So that's going to be plus 18. And now we're going to combine our y terms. So we're going to add 10y on both sides. And you can see those will cancel to 0. And then we end up with 18 and 21. And we know these are not equal, so we're going to write that is not equal. So this means no solution. All right, so for example 3, we want to create equations with no solutions or infinitely many solutions. Now, before we do this, I want you to write down this chart, okay? And this one, I want you to write the whole chart, okay? Including the examples. All right, so for this table, you've got no solution, one solution, infinite solutions. The equations, this is what they look like. Okay, so I do want you to have that in the table. Now, remember, coefficients, those are the numbers in front of the variable. Okay, now, if you look at the first, for no solution, look at the coefficients. See, they are the same, right? They are the same. You with me? 6 and 6, they are the same, right? The constants are what? The constants are different. So this, different. For one solution, just like we've been doing the whole time, you see that the constants, let me delete that, the constants, they can be either different or the same for one solution, okay? And for the coefficients, they have to be different. Because if they were the same, then they would cancel out to 0, right? So they have to be different. And then for the infinite solutions, if you look, the coefficients are the same, and the constants are the same. Oops. And the constants are the same. Okay, make sure you fill that in. Now, we want to complete the equation with values that will result with infinitely many solutions, no solution, or one solution. Okay? So let's start with infinitely many solutions. Now, if we want infinitely many solutions, what do I need? I need the same coefficient and I need the same constants. Now, look at how the equations, the expressions up here are written. 2 terms, 2 terms. 2 terms, 2 terms. 2 terms, 2 terms. Down here, too many terms, right? So we need to simplify this so that we have two terms, a binomial. Is everybody clear? All right, so let's simplify. First thing we're going to do is we're going to use our distributive property. Very good. So we've got 4x minus 2x minus 10, right? And now we've got a 4x minus 2x, which is a 2x minus 10, and now I have a binomial. And if I want infinitely many solutions, we said we want to have the same coefficients and the same constants, right? So what goes in here for the x, for that coefficient? 2 and 10. So 2x minus 10, that is going to make this equation have infinitely many solutions. So now we want to know, what are we going to put in there into that equation so that there are no solutions? Now, if we want no solution, the coefficients need to be the same and the constants need to be different. So, what am I going to put in my first blank? Has to be the same coefficient, right? So what am I going to put in there? 2. So this is going to say 2x and minus what? Anything. Anything but 10 because it needs to be different. 26, 85, 3. Is everybody clear? Everybody got it? For one solution, the coefficients need to be different. And the constants can be either the same or different, doesn't matter. Is everybody clear? So, what am I going to put in for my first blank? Anything but 2. So, how about 8? 8x. And then, what am I going to put in for my second blank? Anything I want, right? Anything you want. 10, 16, 85, 42. Anything you want. All right, so here's extra example 1. Now, we are going to decide which one of these has infinite number of solutions. Now, remember, when we have infinite number of solutions, we have to have, they have to be equal on both sides. So A equals A. Okay, that's what we're looking for. So first thing we want to do is we want to simplify both of these. Okay, so we're going to use our distributive property and use our distributive property here. Oh, good thing this one will simplify. Okay, so this we're going to end up with 3a plus 9 minus 2 is equal to, and here 1/3 times 9, that's equal to 3. So you can simplify right there. Okay, but I'm not going to write it because I got to do it for the other one too. So that's going to be 3a minus, and that's going to be 2. 1/3 of 6, 2. So now we can combine some like terms. Here's my equal sign line. And here I've got positive 9 plus a negative 2. So here we've got 3a plus 7 equals 3a minus 2. And now we're going to subtract. We've got a 3a here and a 3a there. We're going to subtract 3a on both sides. So those cancel to 0. And here we end up with a 7. 7 is equal to negative 2. Well, we know that's not equal to So this one is does not have infinitely many solutions. This one has no solution. All right. So that means the other one has to have infinitely many solutions, but we're going to prove it, okay? So we're going to use our distributive property to simplify. We end up with 18 minus 12g is equal to negative 12g plus 18. Okay? There's my equal sign, dotted line. Okay, and I want to combine my constant terms, my variable terms. So here we are going to add 12g on both sides. So those 12g's cancel to 0, and we are left with 18 is equal to 18. That's what we're looking for. So this one has infinitely many solutions. All right, so extra example number 2. This one we want to find which one of these has no solution. And if we're looking for no solution, that means that it has to be not equal to each other. So it has to say A is not equal to B, okay? So we're going to use our distributive property again. We're going to distribute the 5 throughout the parentheses, and we're going to distribute this 1/3 throughout the parentheses. So that's going to give me 5c plus 5 minus 12 is equal to 4c minus 8. And here's my equal sign, dotted line. And I can combine my like terms. So I've got a positive 5 and a negative 12. So on the left-hand side, we've got 5c minus 7 equals 4c minus 8. Okay? And now we are going to combine our variable terms. So we're going to subtract 4c on both sides. So these 4c's, those cancel to 0. And we're left with 5c minus 4c, that's 1c. So that's c minus 7 is equal to a negative 8. And now we'll add 7 on both sides. And c, those cancel to 0. And c is equal to negative 1. So this one has one solution because it says c is equal to something, okay? So this is one solution. Okay? So now we're going to look at example B. We're going to use our distributive property, and I bet you this is the one that's going to be no solution. One other equation. So we've got 6x plus 10 is equal to 10x minus 25 minus 4x. Okay? Here's my equal sign line. And then we can combine our like terms. So on the right-hand side, we've got 2x terms. So 10x minus 4x is going to give us 6x. So on this side, we've got 6x minus 25. On the other side, we have 6x plus 10. And now we are going to combine our x terms. So here we're going to subtract 6x on both sides. Both of those 6x's, both of those combinations cancel to 0. So we are left with 10 is equal to negative 25. Well, we know that 10 is not equal to 25, so that tells us that this one has no solution. That one is no solution. All right, so for our extra example number 3, we want to know, we want to complete this equation so that it will result with no solution, okay? Now, if we want no solution, then that means we want the coefficients to be the same, and we want the constants to be different. And don't forget, we want to simplify this so that we have a binomial. Has to be two terms on both sides, okay? So, let's see, we've got some like terms that we can combine. There's my equal sign line. So we're going to combine our like terms. We've got a negative 3x, we've got a positive 8x, and we've got a negative 1x. So, negative 3x plus a negative 1x, that's going to give me negative 4x plus 8x minus 6. And now I can put those x's together. So, negative, we could do it all at one time. I'll just do it step by step. So, negative 4x plus 8x, that gives me 4x minus 6. So we want to know what goes in each of these blanks. So again, no solution. We want to have the same coefficient. So that means we want this to be 4, and we want the constant to be different. So anything but 6. So I'll choose 3. So 4x minus 3, that is going to give me no solution.